Today we will look into all the properties of limits. We will also learn how to evaluate limits by the method of direct substitution. In our previous video, we learned how to evaluate limits using the left hand and right hand limit. Click this info card to learn that now. So today we will learn another method to evaluate limits. This is called the method of direct substitution. So let's take this example. We are asked to find the limit of x minus 2 as x tends to 5. Here we simply substitute the value 5 for x into our function. So that would be 5 minus 2, giving us the answer 3. So this should be our first go-to method when answering any limit question. Later on, we will learn more methods of evaluating limits. Now let's move on to the properties of limits. So here, for the following properties, let's assume that the limit of f of x as x tends to a and the limit of g of x as x tends to a exists. So for the first property is when we find the limit of a constant. So the limit of any constant is equal to the value of the constant. For example, the limit of 5 when x tends to 3 is equal to 5. Since we have no x variable in the function, we don't mind the value of where x tends to. So the answer will be the value of the constant. The second property is the addition and difference of functions. When we are given a sum of two limits, we can separately find the sum of each limit and then add them together. This is the same situation when we are finding the difference. We can assign the limits separately to each function and then subtract and get the final value. For example, if we have to find the limit of x squared plus 5x minus 2 as x tends to 3, we can separate them to get the limit of x squared as x tends to 3 plus the limit of 5x as x tends to 3 minus the limit of 2 as x tends to 3. So using the method of substitution, we can get 3 squared plus 5 into 3 minus 2, giving us the final answer 22. So the third property is when finding the limit of a product of two functions. In this case, we also can separately find their individual limits and then multiply their respective values. For example, if we are asked to find the limit of 2x multiplied by 3x as x tends to 3, we can write them separately as limit of 2x as x tends to 3 multiplied by the limit of 3x as x tends to 3, giving us 2 into 3 multiplied by 3 into 3, giving us the final answer 54. So now we come to the fourth property of limits. So this is when we are finding the limit of a quotient or the limit of fractions of two functions. Here also we can find the individual limits and get the final answer. So if we are asked to find the limit of sin x over cos x as x tends to 0, we can write the limits separately as limit of sin x as x tends to 0 divided by the limit of cos x as x tends to 0. So this gives us sin 0 which is 0 and cos 0 which is 1. So the final answer will be 0. There is another way of evaluating quotients. Depending on the question, this property will become of good use. So this is that the limit of f of x divided by g of x as x tends to a can be written as 1 over limit of g of x divided by f of x as x tends to a. We will see this in our following videos where it will be very useful. So now let's go to the next property. So this is when we have a constant together with a function. We can remove the constant out and evaluate the limit of only the function. So for example, if we are given to find the limit of 5x squared as x tends to 3, we can take 5 out and write limit of x squared as x tends to 3. So that will be 3 squared multiplied by 5, giving us 45. So for our next and final property, when we need to find the limit of a constant to the power of a function. So here also we can remove the constant out and find the limit of only the function. So if we are given to find the limit of 5 to the power x as x tends to 3, that will be equal to 5 to the power limit of x as x tends to 3. So that will be 5 to the power 3, giving us the answer 125. So those are the basic properties of limits. These properties are very important when evaluating limits. So to get used to these properties, we have some exercises in our description below. The answers are also given for your reference. Until we meet again, take care.